tell you the most important things you need to know about ocean energy and all the different ways that we are exploring to use our ocean resource as an energy resource. So there's lots of different categories that our ocean energy resource falls into, depending on if you're talking about taking advantage of tides or currents, wave, thermal differences, salinity differences. There's all sorts of ways we can make use of our ocean as an energy resource. Bringing it down to the United States and what the potential looks like here, most of the ocean energy potential in the United States is in Alaska, which obviously is not where some of our highest demand centers are. But if you think about remote places, ocean energy could be an option for remote towns and villages that don't have access to a lot of other resources to take advantage of some local resources. So just looking back to global in terms of how much electricity is actually being produced from the ocean today is a very, very small portion of our global electricity. And so you can see this is just showing you for 2 years, 2022 and 2023, compared to our other renewable energy resources. Ocean is about 2 terawatts. Most of the installed capacity is somewhere around, half a gigawatt. It is not significant, and you can see it's not really growing. There isn't a lot of growth going on in our electricity production from ocean, but there is kind of a steady stream of public and private investment that is interested in this space. So there's lots of issues with ocean energy in terms of environmental impacts. And some of those have been studied, but are not super well understood because we're not taking a huge advantage of the ocean as an energy resource. So a lot of these things won't surprise you. We have wildlife impacts, local effects in terms of how it's going to impact the temperature of local oceans, depending on the technology, or things like cutting off estuaries from the ocean so you can have water quality impacts. Siltation in some of the technologies, so similar to what we see in hydroelectric dams, you can have buildup of sand. You can interfere with how shorelines naturally progress. So our shorelines and our beaches are not stagnant. That sand actually moves around a lot, and so we can have impact on how that sedimentation process takes place, depending on how we're taking advantage of the ocean resource. Like I said, temperature changes, releasing CO2 from deep ocean water, if we're bringing that up to the surface. We also have impacts with how humans are using the ocean. So whether that's shipping, fishing access, recreation. So those can be competing uses of the ocean places. And then we see things like NIMBY, not in my backyard, people not wanting to see some of these facilities on the coastlines, especially in places that might be tourist places. So you can see there's a lot of challenges with our ocean energy kind of across the board and all the different ways that we can take advantage of the ocean energy resource. So I'm going to take them one at a time and talk first about our kinetic resources. So kinetic just means we're taking advantage of the actual movement of the ocean. And so the big prominent kinetic energy resource would be our tidal energy resource. So our tides are driven by the gravitational pull of the moon and the sun. And the nice thing about tides is we know exactly when and how big a tide is going to be. So we know it is very, very predictable to the hour of how big and how much. But it is not dispatchable in the sense that we can't change it. And so it isn't going to match load patterns. So you would need to match a tidal resource with something else that is able to flex up and down to match supply to demand when you're generating electricity. There's two ways we take advantage of our tides. Something called tidal barrage. Think of that like a hydroelectric dam. So you can take advantage of tides that way. And tidal currents. And just think about that as, like a river, flowing tides in our oceans. We categorize our tidal resource by the range of the tide, how high it gets, and the volume of the flow, how much water is actually moving. So the first way we take advantage of it is in a tidal barrage power plant. Like I said, this is just like having a hydroelectric dam. So you have to build a dam across an inlet all along the coastline. And so you're separating that inlet from the ocean. You allow the tide to bring the water into that inlet during high tide, and then you run the tide back out through the hydroelectric dam when it's low tide. This is the largest ocean resource that is installed today. It's over 90% of total installed capacity at two power plants. One in France that has been in operation since the 60s. The other place is in the Republic of Korea. There is the largest facility. It's just slightly bigger at 254 megawatts, providing about enough electricity for a city of 500,000 people. Okay, so the second way we can take advantage of our tide is tidal currents. And this is different, and it's going to be better in different locations because with a tidal current, what you really want is the tide squeezed between two land masses. So a lot of times that's between a shoreline and an island. If you're squeezing the water between her, you're going to get faster currents for the same amount of tide. And so we see this in Scotland. Some of the islands offshore and the shoreline squeeze that tidal resource, and you have a more significant current. Okay, so that's tides. We also can take advantage of kinetic energy in moving water from our ocean currents. This is also a space where we're not seeing a lot of action. So our ocean currents tend to have a lot slower moving water than actually our tides. It is steady. It's also very important for weather patterns. There's a lot of concerns about taking some of the energy out of our currents and how that would affect the ocean currents themselves because they're so important. But we do have some small prototype systems, like Japan is looking at this, but not a lot going on in this space, even on the research and development side. Okay, the other kinetic way we can use for moving water are wave energy. And waves move differently than our currents because wave energy is actually a rotation of the particles and they're hitting each other and they're rotating like that. And so it's not actually the movement of water. We have to take advantage of this rotational energy in the water that's hitting each other and making these waves. So there's kind of three different ways we can do that. We can do it with something called a wave surge or focusing, where you're basically the waves are crashing over something and then running back through like a turbine. We can use something called an oscillating water column, where you're taking advantage of the waves coming in, pushing air through a turbine, and then they would come back out. They pull the air back through the turbine. And then there's floating or pitching devices. And these are taking advantage of the up and down or the rotational movement of the waves and trying to convert that into pumping a fluid or something else that can be used to turn a turbine and generate electricity. I would say wave energy is really where we see a lot of innovation and interest, but not a lot of longevity in actually providing electricity to the grid. It is a very tough environment for these kind of systems to survive. Okay, so those are our kinetic resources. The other big way that we can take advantage of our ocean is something called ocean thermal energy conversion. In this case, you're taking advantage of the fact that the temperature at the surface of the water is warmer than the deep ocean. So in places where you have at least a 20-degree difference between the surface and the deep ocean, you can actually use that temperature difference to run a thermal power plant. Now, a 20-degree difference between your hot and your cold when you're running a steam cycle or, a thermal power plant is not very big. And so the efficiency of these are going to be relatively low. So ocean energy also is not seeing a lot of investment compared to our other renewable resources. Partly from the challenges, a lot of the technology is not ready for mass deployment. So there's a lot just in the research and development stage, whereas things like solar and wind are really cost competitive with the traditional energy resources, and so seeing a lot of investment. Finally, I do want to say that the governments are really important for research efforts. And so one of the things that the US government has done is set aside a place off the coast of Oregon as a research area that is grid connected. And just having that kind of pre-permitted area allows researchers, developers, startups to go try out their designs and technology in a very easy way. That's all I've got for things you need to know about ocean energy. If you want to see the full lecture about it, you can check out the video on our website and other facts about it. And of course, I encourage you to join our Energy Spotlight.